In this lesson, we'll review probability so that you can remember how to do this for your test. First of all, to calculate simple probability, we have to take the total number of the desired outcomes and divide it by the total number of possible outcomes. Let's use an example. What is the probability of randomly choosing a jack from a standard deck of cards? Here we see the notation for the probability of a jack. Well, first of all, we have to remember that there are 4 jacks in a deck. 4 jacks, 4 queens, 4 sevens, stuff like that. So our numerator of our ratio is 4. Then we have to do the total number of possible outcomes, where there are 52 cards in a single deck. So our denominator is 52 and our numerator is 4. If we can, we need to reduce. Well, 4 out of 52 does indeed reduce. We can divide the top and the bottom by 4 to get 1 out of 13. So the probability, or the likelihood, of randomly choosing a jack from a standard deck of cards is 1 out of every 13 tries. Let's look at independent probability. This is the probability when the event of the second is not affected by the probability of the first event. There are some situations that we have for independent probability. Well, you may pick a card and replace it. You may roll a pair of fair number cubes, or you can roll the same number cube multiple times, or you could spin a spinner. So let's look at our example. What is the probability of rolling a 5 on a fair number cube and then getting a blue on a 4-colored spinner? Again, you'll see here, this is the notation that we have for the probability of getting a 5 and then spinning a blue. So let's do the first is probability of rolling a 5. Since rolling the die, or the number cube, will not affect the probability of the spinner, we use independent probability. Remember, in independent probability, the denominator will not change. So let's look at probability of 5. There is one 5 on a die out of 6 faces. So the probability of getting a 5 is 1 out of 6. The probability of getting a blue on a 4-color spinner, assuming that there are 4 different colors, is 1 out of 4. Notice the denominator did not change because the first one did not affect the probability of the second one. So we just simply multiply across. 1 times 1 is 1. 6 times 4 is 24. Remember, you always want to reduce if you can. The next one we're going to look at is dependent probability. Dependent probability is whenever the chances of the second one are affected by the first one. There are some examples of this. One is when you take more than one item, or taking 2. The next is taking an item out and not replacing it. So let's look at this example. What is the probability of getting 2 cards at random and picking a pair of 3s from a standard deck? Well, the probability that my first one is a 3, well, there are 4 3s out of 52. And as you could see, I've reduced it by 4 on the top and the bottom. The second one, there are now 3 3s left in the deck because I've already picked out 1 3. So the probability of the second one getting 3 is now there's going to be 3, but since I already have this card out, there's 1 taken away. There are 51 cards left. This too will reduce. We'll reduce that by 3, and reduce this by 3. So the probability of getting 2 3s in a row is 1 out of whatever 13 times 17 is. I'll let you guys do this one on your own. The last section is making predictions. This is pretty much the main reason why you learn how to do probability. Here's where we use the experimental probability to estimate for a whole population. There are 3 steps to being able to make a prediction using probability. The first is to set up the experimental probability as a ratio. next is to set up the prediction probability as a ratio. Remember, in this situation, there's one part that we don't know. And so that's the reason why we'll be able to use proportions. So the next part is to set them up as a proportion and solve. Let's do an example. What is the favorite color of students at Highland Park? Since there are 1,100 students, Landon chooses to randomly survey 165 students at Highland Park. Out of the 165 students surveyed, 55 liked blue, 40 liked pink, 30 liked red, 25 liked black, and 15 liked purple. In this situation, it gives us the total number of students surveyed. If we didn't get that information, we'd still be able to solve this because all we have to do is add all the different ones that chose, and we would find out that there were 165 students that Landon surveyed. So, out of 165, how many people liked blue? 55. Since that was the one that was the most, we want to find the favorite color. We're going to choose our experimental probability of blue as 55 over 165. Our next step is to set up the prediction probability. We want to know how many students like blue out of the entire campus of 1,100 students. So we're going to have our question mark, this is something we don't know, how many wanted blue, over the 1,100 students. At this point, we're going to cross multiply and divide 55 times 1,100 and then divide by 165. Why don't you multiply that, divide by 165, and see what you get as your answer. Bring it to class tomorrow, and we'll see if you got it right. Good luck.